Welcome to our today's EMAG webinar, Shaft Machining. Why vertical turning centers are ideal for this topic. My name is Alexander Neumeister. As head of engineering in the Shaft Technology Department, I'm responsible for the customer project. With me is Andreas Droffel, product manager for shaft turning machines and technology expert. In all our live webinars, you have the opportunity to ask questions to us, which we can answer live or afterwards. Please use the chat function. On the left side, your name will be shown. On the right side, if you have questions, use the question tab and you will ask us anonymously. So don't hesitate. If you have any questions, ask us. Let's get started. You basically know two machining strategies of turning shafts, horizontal-wise or vertical-wise. EMAG clearly opted for the vertical turning strategy. From our point of view, it's the best and most suitable machine concept for our customers. In the next 45 minutes, we would like to show you the advantages in using a vertical turning center from our VTC series. In the beginning, Andreas Droffel will give you an insight to the machine technology and its wide range of applications. In the second part, I will show you how versatile and efficiently these machines can be linked together. Now, I will give the floor to Andreas Droffel.
Thank you very much. So, welcome. And what I want to show you first is the machine structure, the working area of the machines and the footprint of the machines. And the VT machine is a construction kit, so in the second point we want to have a look on the modular design of the machines and the options for configuration. Integration of technologies is point 3, and at last we will have some application examples. So first of all, the machine structure. Here you see our main body of cast granite. The main spindle is implemented. Main spindle is movable in the vertical axis. The cable chain, the tailstock on the lower side is fixed. Some housings. The turrets on the left and the right side. Cable chains, our standard automation on the left and the right side. And you see the working area is good reachable for changing tools or something else. We have our energy compartment in the back and the swerve conveyor. And now we see first example, it's an injector body. The left turret with a gripper is loading the part. We're doing the end finishing of this part with the special tools, centering and length. Drilling operations. Now we support with the tailstock and do the rough turning with 4 axes. And finish the part. Now a tangential rolling head will do the thread. And after this, the right turret with a gripper will unload the part to the right side automation. So have a look for the working area of the machine. On the right side, you see our common configuration. It's a spindle on the upper side, as I said, it's movable. We have a tailstock on the downside. In the background you can see the steady rest, and on the left and the right side are our turrets for the tools. And we built the machine in two sizes. First is a smaller one, is a VT2 or VT100 for workpieces up to 100 millimeter in diameter, and the bigger machine, the VT4 or VT200, up to 200 millimeter in diameter. The VT2 and VT4 shows us it's a machine with a FANUC control unit, and the VT100 or VT200 is with Siemens control unit. We built the machines for 160 or 250 millimeters for chuck diameter, so the smaller one 160, the bigger one 250. And maximum part diameter, as I said before, 100 or 200 millimeters. Part length is with 400 millimeters or 630 millimeters. And the gripper on the both turrets are up to 100 millimeter in diameter and 125 millimeters in diameter for the bigger machine. The footprint of the machine, here an example of VT2 or VT100, including automation and chip conveyor. The depth is 5.1 meters. For the bigger machine, the VT4, it's 5.6 meters. The width is 2.4 meters for the smaller machine. For the bigger machine, it's 3 meters. And in height, we use 2.55 meters for the smaller machine, with a cable chain 3.4 meters. And the VT4, the bigger machine, around about 2.9 meters, or with a cable chain, we need 4 meters. So the modular design of the machine, so we have a look on the different solutions, how you can configure the machine. We count the rows or track 1, 2, 3 from the left to the right. Track 1 and 3 are for our turrets. And in the middle, track 2 is for spindle, tailstock, what we need. And we equip the turrets on the left and the right side with a BMT55 interface for the smaller machine or 65 for the bigger machine. And each turret has 11 positions for tools and 1 additional position for the gripper. It's also possible to use the turrets with VDI 30 or VDI 40. We can equip all turrets with driven tools and also with a Y-axis. In the middle, you see in the picture the spindle on the upper side and the tailstock on the downside. It's also possible to use 2 spindles in the machine instead of the tailstock, and then we are able to do, for example, op 10 and 20 at the same time in both spindles, and each turret can reach each spindle as you want. Another option is a spindle down and a tailstock movable on the upper side, and all these configurations are possible to use with a steady rest. The steady rest is also movable in the vertical axis, and for the bigger machine it can additionally be retractable when it's not in use.
Andreas, may I disturb you? We got the first customer questions. What is the center distance of the machine, and what spindle power is possible?
Okay. The center distance of the smaller machine is 750 millimeters. For the VT4, VT200 is 800 millimeters, roundabout, a little bit more. But we have options to get it a little bit higher. And the spindle power for the smaller machine is up to 27 kilowatt. and 38 kilowatt for the bigger machine. But we have different spindles for using in these machines.
Okay. So if we need more power than
or less
or
power,
less power, we have different options. Okay.
different options. Okay. So, however, we have two exceptions. There is also a machine called VTC200 CD. CD means it's a center drive machine. There we have only a center drive in the middle, and there's no steady rest in the machine. And the other exception is VTC200EE, what means is a machine for end finishing. EE, because we have two turrets with driven tools for end machining, and each turret has 5 spindles rotating with HSK63 interface for rotating tools. And in the middle on track 2 we use a movable clamping device with 2 adjustable clamping rows for different tool lengths. Integration of technologies. Here we have some examples. First point would be a radio measuring probe. We use it most of the time for measuring the length or the 0 point with a single probe. In this example you see a fork. With this we measure the diameter with the y-axis. We can also engrave with driven tools or skive. We can drilling, milling what you want. Gear hobbing is also possible, or single tool hobbing. Turning out of round is another option. As we have seen in the video before, there was a tangential rolling head for rolling teeth or threads on the parts.
Okay, Andreas, again, may I disturb you? Interesting question. How long does an average tool change take?
An average tool change is depending on the people who do it. It's the first point.
Mostly, yeah.
Second is the interface, or is it Captor, or do you only change the inserts? But in average we calculate with 2.5 minutes roundabout for the first tool after stopping the machine. And for each additional tool we calculate with 1.5 minutes.
Okay, good. Thank you.
You're welcome. Now we have some examples from real life. First of all, we load the part with a gripper on the left turret. In this example, we're doing the measuring of the 0 point. As you see, now 4-axis rough cutting with a phase driver in a special shaft clamping device with retractable jaws. Now we move the jaws forward for better torque and do the rough cutting with 4-axis on the bigger diameter. Now rough cutting 4-axis on the lower side. Finishing. We track the jaws to get better run out. We finish the part, and while we finish the area for the helix, what comes later, the left turret is at the start point for its next operation. Right turret will finish, the left turret starts the right turret chains tool and does the thread turning, and the left turret has a skiving tool on start and skives. Now we go down with the jaws and do the milling. Here with the y-axis. And now we're turning the helix with 4 axes. We retract the jaws and do a finish cut on the clamping area to remove the markings of the jaws. And after this, the right turret and its gripper will unload the part to the right automation. Next example is soft skiving. Normally with small seats or length is not too high, we only use a y-axis, but for longer seats we have to use a z-axis additional to the y-axis. It's not squall-free, but you see it's very fast and you have a very good surface. Also, example with skiving is a rotor package. Doing the upper phase, and after it we do the rough turning with prime turning with 4 axes. And for short cycle time and a very good surface, we use the skiving operation to finish the outer diameter. Here we have an example for loading and unloading through the machine from the right to the left. So we talked about loading through the machines simultaneously with 2 turrets. We can do it from the left to the right, we can do it from the right to the left, but we are also able to load and unloading only on one side. Here we have an example from right to left. Right turret will load the part into the spindle. You see the left turret unloading. Clamp between centers. The left turret will conventional finish one seat and pre-turn for skiving operation. This is hard turning. Left turret is unloading. Right turret gets the next part in the machine. And we start from the beginning. Finishing conventional, pre-turning, and hard turning, squall-free, and unload the part with the left turret.
Okay, Andreas, again, we have 2 questions we got from our visitors. What is the advantage of the spindle on the downside, first of all, and later a different question, what is the quality we can achieve with a hobbing tool?
Okay, advantage of spindle on the downside. Also, what you see later when Alexander does his presentation, you see the possibility to get more than one machine or 2 machines in a row, and there can be an advantage to have a spindle on the downside for the op10 and without swiveling the part 180 degrees. We can load in the next machine. Sometimes for the automation it's better to use a spindle on the downside because the radial orientation or the weight of the part when it goes on the conveyor, the weight has to be on the lower side, not on the bottom of the part, on the upper side, sorry.
So it's a purpose of handling the workpiece.
Yeah. Handling is sometimes the handling is more easy. And because of this, we have these different options. The quality while hobbing is round about IT9, and we do it up to module 2.
Yes.
Yes.
Yeah, securely we say IT9, but in reality we have
better, yes.
we have it better in IT8. Yes.
Yes.
Thank you.
You're welcome. Now we see the hobbing. We do it with a live tool, and the shifting will be done with the y-axis. As you see, it's not only an idea, we do it in real life. And my last example is end machining with a special gripper. So you see on the white turret is a special gripper for loading the parts. That's a short raw part. And in the machine with a part in this loading gripper, the left turret with its live tool will milling the lower end, and we're centering the lower end. After this we go down, and the live tool will finish the length with milling cut and centering on the upper side. And after this, we are ready to clamp the part between centers and start the turning operation. And that's it from my side. And now I want to give back to Alexander.
Thank you, Andreas, for the technical insights of our VT machines. Let's move to automation and interlinking. First, I will show you some standard features to increase your efficiency of the machine. And later I will show you some success stories from the small and compact production cell up to a big, really big production line. A view from the total, from the front, you see the biggest advantage we have in standard configuration is that the simultaneously loading and unloading from the workpieces. The left turret grips a part of the circular storage raw part, and the right turret unloads the workpiece and put it on the finished conveyor. So this saves a lot of time when both turrets are working on the same time. This is the standard configuration. In this state, the VTC machine, or the VT itself, is a standalone machine. You do not need any safety fence or any additional securements. So let us go to the integrated loading and unloading systems. These are the first turret gripper systems. Part of them you have seen in videos from Andreas. First of all, the loading gripper. It can be equipped with a rigid or with pendular jaws, depending on whether you have a raw forging contour or a pre-machined workpiece which has been loaded, or you can have different inserts, different material, so to protect the sensitive surfaces from clamping marks. In the middle, you have the vice gripper. You already have seen for end machining, cutting to length, centering, and then you can immediately turn between the centers. On the right-hand side, we do have the steady rest gripper. Sometimes you have lack of space in the working area. maybe because of you have protruding or long tools in the turrets. So a fixed steady rest is not suitable. So we have here a helpful solution. Those three are the most common gripper systems. Beside them, we have a variety of special purpose grippers, but these are the common ones. For the workpiece storage, there are different options. We have on the left side, the circular storage, and the second one is we can adapt an L or I shuttle for different automation processes, and the single loading position, point number 3, the dot you see. And you can imagine on the right side there will be a handling unit to installed. Number 4, if we do have hard-linked operations, OP10, 20, 30, or even more, we can install buffer conveyors. Maybe you need them if you have different cycle times of the machines, or to reduce downtimes. So when one machine is being set up with new tools, then the other machines can fill the buffers. Some more additional options outside of the machine. I'll show you a short video. For example, here you see some shafts with the inner spline. Outside on the storage conveyor, we have the pallets with the spline, so they are orientated. And the swivel unit brings it to the machine. Now you see why we need it in this way. The mandrel from the upper side meets the spline of the workpiece on the first touch. So no searching is needed. Some more options are height control on the raw side, or type checks if you have several batches of family types workpieces. So to be secured that you do not load the wrong raw parts. Then possible are readers, QR, DMC readers, active position alignments, and on the finished side, some additional measuring devices, or even writing units. I got a question right now. How many workpieces fit on the standard automation? I think that is a question for me. In the standard way, standard circular storage system, you can load 27 workpieces on each side. It depends on the maximum weight. We have a reglementation of the VT2, it's 150 kilograms, and 125 kilograms. The VT4 can load 250 kilograms. So you have to decide how many workpieces is possible, either 27 workpieces or maximum load. So now I will change to some machine link-ups, some success stories I want to show you. Start at the small production cell. Here we see a VT200. On the right side, left side, we have a stacking cell, our EMAG stacking cell, SCS4, linked with a robot. The loading strategy of this machine is only on one side. In this case, on the left one, the cycle time of the machine allows it that we can make a left-left change, raw and finished parts out of the machine. On the other hand, it is a very compact design, so we do not need on the right side an additional space. The stable cell is loaded by an AGV, stacking, and SPC NEO drawer you have seen. The next strategy is the L shuttle I showed you. L shuttle and the single loading position of the right machine VT100. Here we have it combined with a grinding machine with a G160 from IMAC. This is a hard turning and grinding. The robot puts this workpiece on a single load position. The turret of the VT takes it, and end machining starts with it's hard turning with grooving, skiving for the bearings. And this cycle time is so short that we have to change simultaneously left, right, and therefore we don't have the L shuttle installed. The robot takes the turned finished part and puts it for grinding in the G160. And afterwards, it will stacked in baskets. So this was the second strategy of loading and unloading and storage. I come to our most common system. Most common is our track motion, our successful track motion system. I think you know it in the meantime. Here it's a part of a production line. Customer robot loads and unloads the track motion system. We do have in this case 2 VT200 machines with the same operation. Depends on the cycle time. It is a very long running workpiece, the rotor. It loads the I shuttle of the machine on the one side, and it's a through loading again to the right side, and now we see some additional roughing. This you have already seen, and now this is finished turning. In the meantime, the second workpiece is loaded to the additional VT200 machine, even on the I shuttle. And if the right rotor on the first machine has been finished and deloaded, then the track motion picks it up again, moves through a blow-off station and puts it into a measuring and writing device unit. Afterwards, track motion places it on the loading position for the customer robot to take off. Let us go even bigger. I had a question seen. I didn't want to answer it before we come to this page. It left. Maybe it comes again. I got another in the meantime. Why an L shuttle when one-sided loading is also possible? Andreas, may I ask you for answering?
Okay. Yes, L shuttle is only an option to reduce the main time or cycle time of the parts. So the loading through the machine is faster than loading, unloading on only one side. But if you don't have this output of the machine, also you don't need this output of the machine, and the cycle time is not a problem. You can use the machine with one-sided loading, unloading. If the cycle time is a point, we can go through the machine and put the part with the L-shuttle to the working area of the robot. So if you don't need it, you don't have to pay for it. And 1 point for loading, unloading on one side may be the space of the machine, what we need in the plant. And we need, I think, around about 300 millimeters for the L-shuttle on one side of the machine. If this is not possible, we can load and unload on one side.
Perfect. So you got the point. It's a topic between having enough cycle time or enough space.
Yeah.
Yeah. Yeah.
We try to configure our machines and lines for the requirements what our customers have.
Yeah. Okay, thank you. Then second question, bar feeding is feasible in this machine? From the concept itself, it is not possible to have a bar feed on the vertical side or in the basement. But here I will show you how we solved this topic. So in order to dispel the myth that the vertical machine cannot work with a bar feeder, here is the answer. First of all, we have a bar loader and a saw. The saw is the key. We have the shortened, the sawed workpieces swiveled up, turned up in the vertical way. In point number 2, we give it to the track motion system. And now we start the standard way in vertical machining. We have a OP10 roughing machine. We have an OP20 finishing machine. Then we go to the gear hobbing, even a EMAG machine, and track motion transports the workpiece on a cleaning station where the robot cell is linked with, and the robot takes the workpiece, then the measurement is made, labeling, and stacking in baskets in the end. This success story has some key facts, some interesting key facts. The length of the complete production line is 28 meters. The cycle time of the complete line is 90 seconds. So if you imagine to handle 90 seconds in 28 meters, it is not possible to install a horizontal turning lathe. Mostly you need 2 bar feeders, then each machine has 1 operation or maybe 2 operations, but in this case, those 2 VT200 machines are so compact and so small in width that you get the best solution in this case for the workpiece to finish it. In this case, it was a piston. Yeah. So I hope I've answered the question. Is it feasible in a vertical turning lathe without a bar feeder working? This is the answer. How do we get to those complex solutions with our production lines? We are not relying on our experience. We are using professional plant simulation software in this case. So in the offer phase, you give us your workpiece, raw and finished part. You give us your floor, your space, available space, and then we start calculating cycle time. Then we make workpiece buffer design if necessary, if you need setup time optimization or standstill reduction. and in the end you get the amount of spindles you need, and the output calculation is the result, where you can count or say at the end of the day, this is the amount of work pieces that I finish in my basket. This is what we are relying on, because we are working with real machine data, and these results are very good in the practical way in the end. So I'm trying to read this question. No, it's not understandable, so maybe you can start again. So in the end, we had some technology topics of the machine, how it is been built up. We had some options for automation, loading and unloading. And in the end, I want to show you the advantages as a sum up. First of all, we have an unhindered chip flow. The chips are falling down directly in the conveyor. We have short processing times, because we have 2 turrets which can make 4-axis machining. Then we have short non-productive times or idle times due to simultaneously loading and unloading of the machine. We have an ergonomic accessibility to the working area. We have favorable automation options. For example, the circular storages are already included in the standard. We have a flexible automation capability. You can place a robot beside the machine without changing the design. Then we have a small footprint in the width you saw in the last production line, so the concept can be realized in a vast space-saving manner. In the end, easy link up of several machines in a row is no problem with buffer conveyors or shuttles or anything else. So we are at the end of this webinar. I hope you got some imagination of what possibilities eMAG have and which functions or options and feasible points we can make from we can realize from your requirements. I'm looking in the question storage. It is already empty. So there's for me to say, if you have further questions, please contact your local sales team, or you get in the end the email address, the contact of Andreas Trophe. So if you have some specific technology questions, don't hesitate to contact him. And I hope you understand why we are absolutely convinced of this vertical machining strategy of our VT series. In the name of Andreas and in my name, we want to say thank you for your time, and stay in good health. Have a nice week. Thank you. Bye.
Thank you. Bye-bye.